So today we're going to start a couple of sections on solving systems of linear equations. Hopefully that quiz on linear equations went well for you. Next couple of videos are about solving systems of equations. And whenever you solve a system of equations is one that we are solving two separate equations at once. And we're basically finding the point that those two graphs would have in common. For example, the first one, those are two lines. We're going to talk about graphing those two lines and then locating the point that they have in common. Where do they intersect? So we're going to graph the first equation in blue. So since it is in standard form, we are going to find the x-intercept and the y-intercept. And again, to find the x-intercept, we let y be 0. That gives us the x-intercept. So we're left with the equation negative 3x equals 8. So x is equal to negative 8/3, which is negative 2 2/3. Right about in that area. And then to find the y-intercept, we do the same thing, except we let x equal 0, which is basically just canceling out that term. So we're left with 2y equals 8. So the y-intercept is 4. So then the line basically looks like this. All right, so that is the first line. The second line, the x-intercept is negative 8, which is out here somewhere. So I'm gonna leave that for right now. The y-intercept is negative 4. So negative 8. Now, one thing I do know about this, the slope in standard form is the opposite of a over b. If I were to get y by itself and solve for y, subtract the x and divide by 2, I would find that the slope is negative 1/2. So this is where this line goes. And I'm finding the point where the two intersect, which is right there. And that point is negative 4, negative 2, which is the solution to that system of equations. You can do a quick check by plugging negative 4 in for x and negative 2 in for y. In this case, we have 12. Negative 3 times negative 4 is 12, plus 2 times negative 2, which is negative 4. 12 plus negative 4 is, in fact, 8, so it's true for that line. And in this case, negative 4 for x. 2 times negative 2 is negative 4. Negative 4 plus negative 4 is, in fact, negative 8. So that is, in fact, the correct solution. Now, on a quiz or a test, if I ask you to solve these by graphing, the solutions will, in fact, come out to be integers. When we start talking about algebraic methods, we'll talk about some of the pitfalls to the graphing method. Now, in the second example, B, we're going to graph the first line, finding the x-intercepts and the y-intercepts. The x-intercept, let y be 0, so we're left with x equals 4. And the y-intercept, let x be 0. Negative 2y is equal to 4, so y is negative 2. So there is the first line. And the second line, we'll graph in red. The x-intercept is 5/3, which is 1 2/3. And the y-intercept, if we let x be 0, y is equal to 5 for the y-intercept. And when we connect those, we see that the point of intersection, which is right there, is the point 2, -1. And again, we can do a quick check just to make sure we did it right. 2 minus -2, 2 times -1, so which becomes 2 plus 2 is in fact 4. And we have 3 times 2, which is 6, plus -1 is in fact 5. So we know that that is a solution. In the next video, we will talk about special cases for these systems of equations.